Factoring quadratic expressions and solving by factoring. So this is very similar to the last section. The difference is the type of factoring we're going to be doing. In the previous lesson, we learned about factoring GCFs. In this section, we're going to talk about factoring trinomials. And the key to this is noticing that if I start with two binomials and I ask you to multiply them, you end up with a trinomial. And I'm going to skip some steps and just tell you what the answer is. But the point is, if I start with two binomials, I multiply it, I end up with a trinomial. Factoring, we're going to want to do the opposite. We're going to notice that if we start with a trinomial, it should factor as two binomials. And this one happens to be x plus 3, x minus 4. Same thing happens here. If you multiply this out, you'll end up with x squared minus 2x minus 24. So again, that would be called multiplying. Factoring would be going the opposite direction. You would start with the x squared minus 2x minus 24, and you would notice you have a trinomial, so it's going to factor as two binomials, and it turns out to be x minus 6 and x plus 4. Alright, so now of course the big question is, well, how do you know how it started? I mean, it's easy here because you started with here, you multiplied it out. I clearly see I go here, I go backward. How does that work? Alright, so the way it works is, we notice we have a trinomial, 1, 2, 3 pieces. When we have 3 pieces, we're going to write down 2 sets of parentheses. It's got to be x and x, because when we multiply, we would have x times x, which would give us x squared. Then, what else has to happen? Well, just for a minute here, I'm going to put in just some letters, a and b. And when we multiply, we get x squared plus, on the outside, we get bx, on the inside, we get ax, and on the last, we get ab. And I'm going to rewrite this one way, x squared plus b plus ax. So I did kind of a goofy thing there. I took these two and noticed they had a greatest common factor of x, so I pulled it out and then left that one alone. What I'm trying to point out to you here, this looks complicated, and factoring is actually going to be much easier than this once we get going. What has to happen, the two numbers that go in this place, they multiply, and they have to be that number right there. So we need two numbers that multiply to be a 12. And then what else happens with these two numbers? When I add these two numbers, I have to get that. So the b plus the a have to add up to 8. Alright, so in other words, the way we do this, we write these down. We got x and x. Then we need to find two numbers that multiply to be 12 and add to be 8. My guess is that probably most people watching this video are able to tell me the answers right away. Some people kind of struggle with that. What sometimes kind of helps is if you start with 12 and you factor it. 12 could be 1 and 12. It could be 2 and 6. It could be 3 and 4. And then you look to see, when you add these together, do any of them add to 8? And it turns out those two do right there. So our answer is x plus 2 and x plus 6. And again, a really, really great thing about factoring is it's easy to check. I could come off to the side here somewhere, kind of running out of space, I guess I'll do it over here, and I could take x plus 2 times x plus 6, and I could work it out. That would be x squared plus 6x plus 2x plus 12, and I could see that it does turn out to be x squared plus 8x plus 12. I get my original thing back. So that's, again, one of the nicest things about factoring is you can check your answers very, very easily. Alright, so let's try this next one. This next one, I put my two parentheses. It's got to be x and x. Then what I need is I need two numbers that multiply to be negative 15 and at the same time add to be negative 2. Alright, so I start with negative 15. I could do 1 and negative 15. I could also do negative 15 and 1. because notice those I'm sorry, I could do positive 15 and negative 1. Notice that those add up to different things. These two add up to negative 14, these two add up to positive 14. The only other way to get 15 is I could use 3 and negative 5, or negative 3 and 5. These are the two I want, because I notice these two add up to be negative 2. So it's got to be plus 3, minus 5. And I think this is the last time I'll do this. Hopefully you'll do it on a regular basis. I'm going to come off to the side here and I'm going to check my work. That's x squared minus 5x plus 3x minus 15. And I do see that these two add up to negative 2x, and I do have the right answer. Okay, I'm not going to check my work just to save time in this video, but it would be great if you would check your work as you go. All right, let's try this one. X squared minus 3x minus 8. I notice I have a trinomial, so I put my parentheses like so. It's got to be x and x. And then the number negative 8, I could do 1 and negative 8, or negative 1 and 8. I could do 2 and negative 4, or negative 2 and 4. And that's it. And I have a problem. And the problem is, none of these add up to be negative 3. These are negative 7, this is positive 7, negative 2, positive 2. None of them add up to be negative 3. And that happens. What happens in this case is it doesn't factor, and the word we use for something that doesn't factor is prime. Now this shouldn't be a great surprise, because you should be familiar with prime numbers, like the number 5. The only way to factor 5 is 5 times 1. There's really no way to break it down. It's not like 8, which you can break down as 2 times 4. That happens. It's going to be pretty rare in this course that that's going to happen, that things are going to be prime. But here's a good example. There's a prime polynomial. So watch for that. All right, next one. X and x. Let's see. Two numbers that multiply to be negative 40 and add to be 3. Most people, after doing a couple of these, no longer need to write this tree sort of thing down. They're easy to figure it out. They're able to figure it out in their head, and I'm going to expect you to be able to do that. If you need to write this factor tree down, please do. Not a problem if you don't. But most people would come up to see that this is a positive 8 and a negative 5. Now, do be careful of your signs. Occasionally for this problem, I'll see somebody write x minus 8 and x plus 5, which is really, really close. The problem is when you multiply this out, you end up with x squared minus 3x, sorry, minus 40. So be very, very careful that your signs work out. A common mistake people will make is they'll have this last number correct, but the middle number won't be right. And that's why it's a good idea to FOIL it out and check it. All right. Now, you'll notice that all the problems I did so far, there hasn't been any number out front. What do you do if there's something out front? Well, if there's a negative out front, we take out a GCF. So the first thing I'm going to do is I'm going to take out a negative. When I take out a negative, that changes all the signs. That becomes x squared minus 2x minus 8. Because a minus and a minus would give me the plus 2x. The minus and the minus would give me the 8. And then I notice I have something with 3 pieces. So I try to split it into 2 binomials. Maybe I can, maybe I can't. I think I can. X and x. I need to get a negative 8 on this end and a negative 2 there. I think I can do that with a positive 2 and a negative 4. And really, you don't have to multiply the whole thing out to check it. Here's how I check. 2 times negative 4 gives me negative 8. 2 plus negative 4 gives me negative 2. And that's all that really I need to do. All right, next one. Again, we notice this first number is not the number 1, so we look for a GCF. And we see that all 3 of these numbers can be divided by 3. So we pull out the GCF. We have left over x squared plus 9x plus 20. And then we look to see if we can do more. Can we factor x squared plus 9x plus 20? We write the 3 down. We write our two sets of parentheses, x and x. Two numbers that will multiply to 20 and add to 9 are 5 and 4. All right, last one on this sheet. Look for a GCF. All the numbers can be divided by 5, and there's x's in all three of them. So our GCF this time is 5x squared. That would have to be x squared, because 5x squared times x squared would give me 5x to the fourth, plus 2x, 5x squared times 2x, 5 times 2 is 10, x squared times x is x cubed, minus 3, because 5 times negative 3 is negative 15, and I already have the x squared. Look to do more. 5x squared, x, and x. And I think the numbers that are going to work are a plus 3 and a minus 1. Because 3 times negative 1 will give me negative 3. 3 minus 1 gives me positive 2. Okay, that's part 1 for this section. We're going to have a part 2 also. Part 2 will be how do we use this to solve some equations.